Hello, welcome to our video on using radians with exact values and the unit circle. First of all, I want to look at some common examples, common angles in degrees that we'll convert to radians. So these are all degrees. So put a little degrees sign on there. You might like to pause and have a go at converting these yourself, otherwise you can watch to see the solutions. I will remind you that the formula for changing from degrees into radians is radians equals degrees times pi over 180. So for this one we need to do 0 times pi over 180, which just equals 0 radians. And you can continue. I'm just going to give you the solutions you should have. Remember to leave your solutions as an exact answer, so it should have a pi in it. So 90 degrees is pi over 2 radians, 180 degrees is pi radians, 270 is 3 pi over 2 radians, and 360 we already know is 2 pi radians. 30 degrees converts to pi over 6 radians, 45 degrees is pi over 4 radians, and 60 degrees is pi over 3 radians. Now, a place where a lot of people get mixed up is that the 30 degrees is pi over 6, 60 degrees is pi over 3. Don't get mixed up and think 60 degrees is pi over 6. Doesn't work. But if it helps you to remember this 4 goes with the 45, then you can for this one. Okay, how does that work in terms of the unit circle? Well, we have 0 degrees and 0 radians starting here. Remember, we always go around in an anti-clockwise direction. 0 radians here. This was 90 degrees, which is pi over 2. This was 180 degrees, which is pi radians. 3 pi over 2. And then we also get 2 pi radians, which is the same as 360 degrees going all the way around. Going back to our exact values triangles, we had the first one had a 1, 1 and a square root of 2 for the sides, and this is the angle we're looking for. It was 45 degrees, but now we can write it as pi over 4. Here we had an equilateral triangle with the sides 2, 2 and 2, and we put our height in down the middle and end up with square root of 3 for that height. Same triangle over here, but we can put in this angle was 60 degrees, which is, we're writing it in radians now, pi over 3. This one pi over 3. And this one was 30 degrees, which is pi over 6. Okay, what that means for our table of values is we can add in this row here. It's the same table of values as last time, but we've just added in, instead of just having the degrees, we've got the radians values in there. So if you need to find sine of pi over 6 radians, it's 1/2. You need to be able to switch between both of these values and measurements. So you do need to know how these relate to each other, and that needs to be memorized. Seems like there's a big gap in my notes for some reason. Hopefully it's not there in your notes. The next thing I want to look at is how we can find out our reference angles using radians. So a bit of revision here. We've got our point P here, and it says find the coordinates of a point on a unit circle located at an angle of 30 degrees from the horizontal. 30 degrees, which we know now is pi over 6 radians. I'll just put that here, 30 degrees equals pi over 6 radians. What other angles produce the same x value as we have here? We've got this x value, which would be the same as this angle here. And to find this angle, if we're using degrees, it would be 360 minus 30 degrees, which is 330. Got a bit carried away with the zeros, the threes there. 330 degrees. If we're doing this in radians though, we know that all the way around here, the 360 degrees is 2 pi radians, and 30 degrees is pi over 6. And you need to think of these like fractions. So 1 pi radians would be 6 pi over 6. 2 pi radians is 12 pi over 6 minus pi over 6. And we are left with 11 pi over 6, which is equivalent to 330 degrees. I'm not going to put my radian symbol here anymore because we can assume if there's a pi in your number, then it's going to be radians. Let's look at the y value. What other angles produce the same y value? So this is the y value we've got because we're going back to our point P. And the other angles would be this one, which would be the same as in degrees, 180 minus 30 degrees equals 150 degrees. In radians, this 180 over here is pi radians. Pi minus pi over 6. And we said before, pi is 6 pi. 6 pi over 6 minus pi over 6 is 5 pi over 6. So that's our radians value of this angle.